Hello everyone. In today's lesson video, we are going to be looking at forces acting at an angle on Newton's laws. So fundamentally, we're going to be calculating, incorporating our angles. Okay, yes, this is whereby a certain force applied result at an angle. Okay, yes, we're still on Newton's laws, by the way, calculations. Okay, so please guys, don't forget to subscribe. Please subscribe and share the content, the lesson contents, to your friends, classmates, as much as possible. Okay, yes, thank you so much. I can see that the household or the family is increasing right now. Yes, please guys, don't forget to subscribe, mostly to those who haven't subscribed. Thank you so much to those who have subscribed. Let's get into today's topic. Thank you. Okay, so in this situation we have a 12 kg block that is moving, okay, yes, in a surface that that friction is present to, okay, yes. So the 12 kg block is being pulled by 100 newtons, okay, yes, and that has resulted in 30 degrees angle, okay, yes. So that 100 newtons force is acting at an angle of 130 degrees, yes, from our horizontal, okay, yes. Our coefficient of the kinetic frictional force is equal to 0.35. Okay, so mind you guys, so now, okay, so now we're moving to our answers, okay, yes. Moving to our answers. Okay, for A, okay, so for A, they said calculate a friction, okay, yes, we have to calculate a frictional force. So you know that in order for us to calculate a frictional force, we have to first find the value of the normal force acting on that 12 kg block. Okay, so just again before that, okay, I'm going to give you a rule right now, okay, yes, when working with forces acting at an angle, whereby a force has resulted in an angle, just like this scenario. Okay, so the very first thing you should do, you have to find the x and y components. I repeat, the very first thing you have to do, you have to find x and y components, okay, yes, because that angle is not aligned with our horizontal forces acting on that object and vertical forces acting on that object, meaning that that applied force there, okay, that is moving that 12 kg block is partially moving vertically and partially moving horizontally, meaning that we have to find the horizontal, okay, yes, then meaning that we are going to find the horizontal force, okay, yes. So in order for us to find the horizontal force, this is what we call the x component, okay, yes, the fx component, okay, yes, and whereby we find y, this is our y component, okay, yes, or vertical component. Okay, so in order for us to find that, what you are supposed to do, okay, so the very first thing you should do, we should draw a free body diagram, okay, yes, and mind you, we haven't yet answered our question, okay, yes. So let's look for our free body diagram that is acting at all forces acting on that 12 kg block. We have normal force, as you can see, it's on the surface, and we have a gravitational force. we have our FG. There's a friction there, okay? Yes, as you can see, our coefficient of the kinetic frictional force is 0.35, okay, meaning that there's a friction acting on that object, okay? Yes. Let me just say this is a kinetic frictional force, okay, because that object is said to be as moving. Okay, so now we have our force applied, okay, which is 100 newtons, and we have our 30 degrees. So this is the free body diagram for this 12 kg block. The reason why I draw this free body diagram, it's because in order for us to move forward and find the x components that are acting vertically and the y components, we have to first work with our diagram, which is same as free body diagram. Okay, so let's move. Okay, now we're trying to find our x components and our y components, okay? Yes. So this is our normal force, this is our gravitational force that is opposing the motion, which is kinetic frictional force or frictional force, and we have our force applied, okay? Yes, let's just say this is F, okay? Yes, and we have okay, so now we have, okay, our x component, okay? This becomes our x component, okay? Let me say here, this is fx. We're going to say this is fx, and this becomes our y component, okay? And we are going to say this is our f, this side is going to be our fy, okay, standing for the vertical motion of this object, okay? Yes, but in other ways you can just put our fy here, okay? Yes, you can just draw it here, our fy, okay? Yes, our vertical component. Okay, so that's how it goes. You can see this formed a triangle, okay? Yes, whereby we have here 30 degrees, okay? Yes, this has formed a triangle whereby we have 30 degrees there. Okay, so now you know that in order for us to work with angles or with special angles in triangles, this is whereby you are going to use, or I'm going to introduce you again or remind you into our trigonometric ratios, sine, cos, and tan, which stands for tangent in other ways, okay? Yes, so okay, so we have our opposite side, okay? So this is our theta, okay? This side is our theta, okay? Our 30 degrees is our theta. So our theta is opposite to which side? Our theta is opposite to this side, which is equal to 30 degrees. I repeat, our theta is equal to 30 degrees. So which side our 30 degrees or our theta is opposite to? Is opposite to this side, okay? Yes, right next to this side. They're looking at each other, okay, like this, okay? So it's opposite to this side, so this becomes our opposite side. So our fy becomes opposite side. So which side? You can say it's adjacent side there, the side that is nearest to our theta, which is kind of like a base, okay? So I can say this is our adjacent side and this is our hypotenuse side, okay? That's how it goes. Okay guys, I'm going to be very, very slow and explain slowly again. Okay, so in this case now we have to first find our fx, mind you, our x component, and after that find our fy, meaning that our y component, our vertical component of this motion. Okay, so in this case, as you can see, our F is given that is equal to 100 newtons, okay? Equals to 100 newtons, all right? Yes. So in this case, what we have to say, okay, let's look at our angle 30 degrees. Is our angle, okay, let me first introduce you again to our trigonometric ratios. So we have SOHCAHTOA. So this is SOHCAHTOA. This is by sine, okay? Sine is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. So we're using this side. Sine is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse. TOA, which is our tan, is equal to tan theta is equal to opposite over adjacent. Opposite over adjacent, okay? Meaning that this angle here, okay? Yes. Okay, moving. So looking to our theta, or 30 degrees, what sides made that 30 degrees, or what side is our theta or 30 degrees between? Meaning that it's between hypotenuse and the adjacent side, okay? It's between the adjacent side, as you can see, adjacent side and the hypotenuse side, meaning that it's between this line that is made of our x component of our fx, okay, and hypotenuse. Okay, so let's go write that down. Okay, so this basically means that this is adjacent over hypotenuse, and this gives us cos. So that becomes cos 30 degrees, okay? Yes. So so sorry guys, made a mistake here. Okay, so this was supposed to be adjacent over hypotenuse, okay? Yes. So this is adjacent over hypotenuse, okay? Adjacent over hypotenuse, meaning that our 30 degrees is made by those two sides, or it's between those two sides, okay? That angle theta, it's between angle cos theta is between adjacent over hypotenuse, okay? So this becomes adjacent over hypotenuse, okay, is equals to cos 30 degrees, okay? Cos 30 degrees, that's how it goes. So our adjacent said it's fx, okay, over what's our hypotenuse? Our hypotenuse is our vector that is representing the force, okay, our force applied, which is equals to 100 newtons, okay? Yes, let me just say f for now. Let me put variables. So cos 30 degrees over 1. Let's move to the top. So again, made a mistake, okay, so sorry. So adjacent over hypotenuse is equal to cos 30 degrees of x over f is equal to cos 30 degrees over 1. So let's cross multiply right now, or let's substitute first our so fx, we're looking for fx, so over 100, our f is equal to 100 is equals to cos 30 degrees over 1. Let's cross multiply, so this becomes fx is equals to 100 cos 30 degrees. So press on the calculator, therefore our fx is equals to, press on the calculator, 100 cos 30 degrees. Okay, so let me also press 100 cos 30 degrees. So that gives us 86,6, okay, 86,60, meaning that 86,6, okay, 86.6 newtons. Okay, that's how it goes for our x component. Okay, yes, so we found our x component on this motion. Okay, yes, so our x component is equal to 86.6 newtons. Okay, now let's find our y component. Okay, yes, so for our y component, okay, let's look here critically. Okay, so our y component is this side. Okay, yes, which has formed our opposite side. So let's look at this angle which is moving to. Okay, look at this angle. This angle is between the opposite side and the hypotenuse side. Okay, meaning that if ever this angle is between the opposite side and the hypotenuse side made by this opposite side, this basically means that this is going to be let's look, opposite over hypotenuse, which is we're going to use sine right now. Okay, yes, opposite over hypotenuse, okay, so opposite over hypotenuse is equals to sine 30 degrees. Okay, so what's our opposite side there? It's Fy. Okay, what's our hypotenuse? Our hypotenuse is F. Okay, which is equals to 100 newtons. Sine 30 degrees over 1. Okay, let's substitute right now. So our Fy, okay, which is the opposite side over 100, is equal to sine 30 degrees over 1. So let's cross multiply. Our Fy multiplies with 1. Okay, that gives us Fy is equal to 100 multiplied by sine 30 degrees. This gives us 100 sine 30 degrees. Would you mind, please, guys, press on a calculator and look for our 100 sine 30 degrees. So our 100 sine 30, that gives us 50 newtons. Okay, so meaning that vertically, so our vertical component here gives us, or is equals to 50 newtons. Okay, yes, that's how it goes. Okay, so we found our components, our vertical and our horizontal component, meaning that it's going to be easy for now to deal with these problems. Okay, for instance, they said we must calculate the friction. Okay, the frictional force. Okay, yes, and mind you, in order for us to calculate the frictional force is moving in a horizontal motion. We have our x component, and mind you, meaning that now our motion is aligned. Okay, yes, is aligned. So now we can work on our friction or other forces that are acting horizontally, because if ever we can't say 100 and use this force, which is 100 newtons, and combined it with other horizontal forces, because this force is not really acting horizontally, okay, or either vertically. Okay, yes, meaning that it's partially vertically again or partially horizontal. Okay, and now we found our components. Okay, so okay, so let's answer A. So in order for us to answer A, then you can see, guys. Okay, so A, calculate the friction. Okay, let's calculate the friction right now. So our frictional force, okay, know that is equal to U, okay, normal force, mu multiplied by normal force. So okay, let's say this is our kinetic frictional force. Okay, because the object is moving. Okay, so this is equals to 0.35. okay, 0.35 multiplied by the normal force. Now let's go and calculate our normal force. Let's just say like this next to it. So our normal force Okay, you know that our normal force is part of, okay, it's part of the forces that are acting vertically. So let me just say F net, let me just say F net is equal to MA. Okay, yes. Okay, I think it's easy like that. Okay, so let me put it very simple. Okay, so N minus, okay, plus Fy, okay, plus this Fy minus gravitational force is equals to 0. Okay, that's how it goes. You also know that, I believe. So what's our normal force plus what's our Fy? Our Fy is equals to 50 newtons. It's equals to 50 minus what's our gravitational force there? Our gravitational force is 12 multiplied by, let's go and calculate for it. So our gravitational force is going to be equal to 12 multiplied. So our Fg there is going to be 12 multiplied by 9,8. Press your calculator. So 12 multiplied by 9,8 multiplied by 9,8 gives us 117,6. 117,6 newtons. So that's our gravitational force. 117,6 is equals to 0. So 50 minus 117,6. So 117,6. Let me say, yeah, let's say 50. Let's put it like that. Let's say 50 minus 117, comma 6. That's equal to 67,6 newtons. Okay, it gives us N minus 67,6. Okay, newtons equals to 0. Therefore, our normal force is equal to 67,6 newtons. Okay, so we have 67,6 newtons. Then our frictional force is equal to 0,35 multiplied by 67,6. Okay, let's go back to our calculators. 67,6 multiplied by 0,35 0.35 67,6 multiplied by 0,35, 23,66 newtons. This gives us 23,66 newtons. Okay, that's how it goes. So we answered our question A, okay, which is calculate the friction. So we calculated the friction, the frictional force, so I can say. Let's move to B. Okay, so for our B, let me say B here. Our B, calculate the acceleration. Okay, so in order for us to calculate the acceleration, we have to consider some important stuff here. So an object is accelerating horizontally, meaning that it's moving horizontally. As you can see, it's being the force applied. Okay, it's moving horizontally. Okay, not vertically. You can see that it's on the surface. Okay, so meaning that we're going to say, okay, net forces acting on an object is equal to mass multiplied by acceleration. Okay, yes. So what are net forces acting horizontal there? It's your Fx. Okay, it's your Fx. Okay, yes, moving that way, plus okay, a frictional force which is opposing the motion, okay, a kinetic frictional force opposing the motion, okay, is equals to ma. So let's substitute to these variables. So fx, I mean, fx is equals to, what's it equals to? Equals to 86,6 newtons minus the kinetic frictional force is 23,66 is equals to 12, okay, multiplied by acceleration. So press on your calculator, 86,6 minus 23,66. So 86,6 minus 23,66. That gives us 62,94, okay, newtons. Gives us 62,94, okay, is equals to 12a over 12 over 12. Please divide using your calculator, guys. Therefore our acceleration is equals to divide that 62,94 divide by 12, divide by 12. Okay, so 62,94 divided by 12. It gives us 5,22 meters per second. 5,22 meters per second. So that's how it goes. Okay, that's how it goes. Okay, guys, that's how it goes. What I can say here, yes, that's how it goes, guys. So the very first thing that is very important for you is to find our x and y components, okay, so that you can work diligently and freely. And I showed you how to find them, okay, in each and every case. So in other cases, you can just say and know that this angle, okay, this angle that is resulted by a force applied or by a certain force is cos, okay, yes, is cos theta, okay, for your x components, and for the y components it's sine theta, okay. That's how it goes, depending on what the exact number of the angle is, or what theta is equals to. Okay, that's how it goes, guys. So let's move to a second example that I'm going to be doing with you. Oh, I'm full of mistakes. I don't know what's happening today. So sorry, guys. This is 5,25, okay? Because I think it was 5,245. Then we had to round off, okay? Yes. So it's 5,25. I'm so sorry. Let's move to the next example. Okay, so in this case we are given a computer base unit, okay. This is a computer base unit of mass 6 kg is dragged along a smooth desk, okay. Yes, so this desk is smooth, meaning that there's no friction acting against this box moving here, or against this applied force. If the tension of the person dragging it is 20 newtons, meaning that the person that is pulling that computer base unit, the force is 20 newtons, and it acts at 25 degrees above the horizontal, okay, as you can see, okay. So the very first question I'm going to give us to calculate here, I think, is to find the acceleration, okay, and the normal force. So let's calculate the acceleration and the normal force. Let's calculate the acceleration. Okay. Calculate the acceleration. B says calculate the normal force. Normal force. Okay, so let's jump to our answers. So for A, okay, again, before you jump into your answer, you have to first find, okay? It's a must for you to find, okay? As you can see that our force, okay, that is being exerted or applied on that object, which is a tension force, okay? Yes, is 20 newtons at an angle of, okay, yes, 25 degrees, meaning that, and now we have to first find our x and y components, okay? Yes, I think you know the story right now. Okay, so for that 6 kg block, okay, let's first draw its although it's not asked to us to draw a free body diagram. Let's draw it. So we have a normal force, we have a gravitational force, everything on that box. We have that 20 newtons. Okay, this is our F. Okay, this is our F, the force that is applied, and this is our 25 degrees. Okay, and there's no friction there, so that's how it goes. Okay, so in this case, what you have to do, we have to first find the x and y components. Okay, so we have our normal force. Let's draw for our x and y components. Okay, our gravitational force, and we have our force that is moving upwards, the applied force. Okay, which is our F is equal to 20 newtons, right? Then we have our x component, okay, which is going to lie here, which this, okay, which x horizontally 25 degrees. So that's how it goes. This is our fx, okay, x component, and this becomes our y component. Okay, so if ever, okay, so you have your angle here. So in order for you to find all of the sides, you must first consider the angle. This is 25, okay, 25 degrees. Okay, so this angle is opposite to which side? Is opposite to this side, okay? Yes, that is Fy, that is made by the vector of Fy, okay, which is a vertical component. Okay, this becomes our opposite side, this becomes our hypotenuse side, and this becomes our adjacent side, okay? Yes, our adjacent side, which is made by or created by Fx, okay? Yes, and so now let's find our x and y components. So let me just write here. So I'm not answering the acceleration yet, okay? Yes, let me just say cancel here. So let me move this side this way. Okay, so guys, this angle is between the adjacent over hypotenuse. So you know that, so okay, adjacent over hypotenuse is cos the adjacent over hypotenuse. This is the angle between the two, okay? Yes, so the adjacent over hypotenuse is equals to what? Is equals to cos 25 degrees. Cos 25 degrees. What's our adjacent side? Our adjacent is fx, okay? Let's substitute the variables. It's fx over, that's our hypotenuse, it's f, okay, which is equal to 20 newtons, equals to cos 25 degrees. So our fx over 20 over 20, this is 20, is equals to cos 25 degrees over 1. Let's cross multiply right now. So f of x cross multiply, okay, this gives us f of x, okay, x multiplied by 1, fx, fx ish. So this becomes 20 multiplied by cos 25 degrees, 20 cos 25 degrees. Okay, so let's press our calculators. Therefore our fx is equal to, let's press, okay, 20 cos 25 degrees, 25, this becomes 18,13, okay, newtons, 18,13 newtons. So it goes. Okay, so now we found our x component. Let's find our y component. So you know that for our y component, let's look here, okay, opposite over hypotenuse, okay, let's look here. Yes, our y component is opposite over hypotenuse. So what's our opposite over hypotenuse? Opposite over hypotenuse, opposite over hypotenuse, it's sine, goes with sine, okay. Yes, this is sine, okay, this is cos, this is tan theta, okay. Yes, so goes with sine, opposite, okay, you can see our fy, okay, opposite over hypotenuse, okay. Yes, so this becomes opposite over hypotenuse is equal to sine, okay, sine, opposite over hypotenuse, sine what, 25 degrees, opposite over hypotenuse. So what's our opposite side there? Opposite side, it's fy. So fy is over adjacent. What's our adjacent? I mean over hypotenuse. So I thought it's f, okay. Yes, is equals to sine 25 degrees. So therefore our fy over 20 newtons is equals to sine 25 degrees over 1. Let's cross multiply to get our fy. Our fy is equals to 20 sine 25 degrees, and therefore our fy is equals to what? 20, press on your calculator, 20, okay, 20 sine 25, you can also say multiply by sine 25, okay, is like that. So it becomes 8,45 newtons, 8,45 newtons. That's how it goes, okay, that's how it goes. So we find our vertical component, okay, in that case, which is equals to 8,45 newtons. Okay, so guys, I'm full of mistakes, okay. I might see on my calculator that the answer is right as it is, okay. Yes, but I might write a wrong answer, okay. Yes, so please, if ever made a mistake, don't worry, I'll notice it as time goes, but please try to understand that I'm full of mistakes. Okay, so 8,45 newtons. Okay, so we find our x and y components, and now what we have to do, we have to calculate the acceleration. Calculate the acceleration. Okay, let's calculate the acceleration. So the object is accelerating vertically, okay, it's moving vertically, as you can see in this frictionless surface, okay. There's no friction, meaning that, okay, our net force is equals to ma, okay. So what's our net force there? Our net force is our net force acting there, it's what force is acting there? It's Fx, okay? Fx is equals to only Fx, okay? Yes, horizontally, okay? It's our Fx horizontally. You know the value of Fx, okay? Over what's our kg? It's 6a. Therefore, what's our Fx? Our Fx is equals to 18,13. I think now you can see why it's very important for us to first find the y and x the y and x components. Yes, I think you can see, guys. Okay, yes, because this is our x component. Okay, therefore, would you mind please pressing the calculator? Therefore, our acceleration is equals to 18,13 divided by 6. So 18,13 divided by 6. That gives us 0,02 meters per second squared. It gives us 3, hey, what I'm doing right now. This gives us 3,02 meters per second squared. Okay, so this is our answer. Okay, 3,02 meters per second. Okay, yes, so that's how it goes, guys. Yes, so now let's calculate B. Calculating the normal force, okay, acting on this object, okay, on this computer base unit. Okay, so you know, in order for us to calculate the normal force, okay, the normal force, okay, so again, the normal force, you know that the normal force, okay, let me put it simple, okay, let me say F net is equals to MA. Okay, what are all net forces acting on that object, on that 6 kg block? Meaning that we have that vertical forces, okay, yes, because we're calculating for the normal force. So you have your normal force plus your Fy, your y component, okay, minus Fg is equal to MA, mass multiplied by acceleration. So this gives us Fn. Let's substitute to the variables, okay, Fn, our normal force that we are looking for, plus what's our y component? Our y component is equal to 8,45 newtons. 8,45 minus what's our gravitational force there? So our gravitational force is let's calculate our gravitational force. Our Fg there is equals to mg. This is equals to 6 multiplied by 9,8. Please press on the calculators, guys, also. And one of the reasons why I say please also press on the calculators, guys, is because so that you can be able to see when I made a mistake with my calculations, okay? Yes, and that makes things very easy. So 6 multiplied by 9,8, that gives us 58,8. Gives us 58,8 newtons, okay? So that's the gravity acting on that 6 kg block. So it's 58,8 newtons is equals to 6 multiplied by 3,02, okay, our acceleration. So now our normal force is equals to, okay, 8,45 minus 58,8, okay, press the calculators. 8,45 minus 58,8, that gives us negative 50,35. Negative 50,335 is equal to 6 multiplied by 3,02. So 6 multiplied by 3,02 gives us 18,12. 18,12. So sorry, it's not 12, it's 12 after the comma. Okay, so 18,12. So therefore our net force, our normal force, so sorry, our normal force, okay, is equals to 18,12 plus 50,35, because that one goes that side. Okay, yes, I just want to make it sure, guys, so that you don't get confused. So 18,12, okay, plus 50,35 plus 18,12 plus what? Plus 50,35. 50,35, that gives us 68,47. 68,47 newtons. So this is our normal force in this scenario. Okay, so that's how it goes, guys. Those who haven't subscribed, please subscribe to the channel for more lesson contents, etc. I'm so sorry again for my mistakes, guys. I'm one who's big on mistakes. Okay, yes. So but in each and every time you deal with this kind of calculation, you can just pause the video and try to calculate at your own and see if the answer is correct. That's other way of effective practice through your own learning. Okay, guys, I'm going to see you in the next following video. Thank you so much again. Please, when dealing with forces acting at an angle, okay, forces acting at an angle, okay, or forces that result at an angle, okay, applying a certain force on an object, please, you must first know it's vital, okay, it's very vital to find the x, or to get used to finding the x and the y components. I repeat, the x and the y components, okay, and I showed you how to find them and where does that comes from. Okay, lastly, don't forget to subscribe, guys. Please subscribe right now to that red subscribe, just click it, that red subscribe button. I'll see you in the next following video. Bye, cheers.